Good afternoon, one and all. I welcome you all to the last session of the for ATAL FDP, that is session number 14, and we will continue the session on natural language processing by Mr. Sylvester Daniel. So,
Yes, ma'am, I can hear you. Can you hear me?
okay, sir. Yes, sure, sir. Over to you, sir. Thank you.
Yeah. Thank you, ma'am. Good afternoon, everyone. I hope all of you had good lunch. I think I'll have additional challenge of ensuring I don't help you guys sleep better. So I'll do my best. With that in mind, I planned the demo for the later part, so I can help you stay awake. Okay, with that, let's get started. Once again, thank you everyone for joining the session, taking your time. I don't have much slides for this session. I wanted to do more demo, more hands-on, so that you get a feel of what I spoke in the previous session. I'll refer to the slides, what we discussed in the last session now and then to relate to what I'm going to demo. Okay, so that will be the way we will drive this session. With that, so if you remember, we discussed various tasks, and then we spoke about the importance of annotation, right? So the first step in AI or any machine learning model development is understanding the data, preparing the training data suitable to the model for training, right? So with that, in the previous session, we spoke about Label Studio. Um, we have unlabeled data. The machine learning model kind of predicts when the unlabeled data comes in because, again, like I said, we mostly deal with pre-trained model, right? So it predicts, and then you kind of view it, review it, or correct it, annotate it, and then whatever you save can be automatically used for training. The whole process is called active learning, right? So just trying to brush up some of your memories. And this is how a screen would look for in ER, correct? So with that, let me show how to use Label Studio, how we use with a very simple example. I have set up Label Studio already in my machine. If you want to check out what is Label Studio, how to use it, you can go to this URL, labelstudio.io. You can check its capabilities. It is open source. I believe it is Apache license, so you should be able to freely use it and customize it. Okay, so on Label Studio, it's a data labeling tool. We have also kind of little bit enhanced it to use it as a review tool, and wherever for whatever tasks, NLP tasks, it doesn't support active learning. We have,
Excuse me, sir.
yes, ma'am.
Sorry for the interruption. So we couldn't able to see your screen. We have no idea whether you have shared the screen. That's why.
Oh,
Sorry for the interruption, sir.
no, absolutely. It's good you interrupted because I've been assuming I'm sharing my screen and talking all the time. Very sorry about that.
Okay, sir.
Yeah,
Thank you,
like I
sir.
said earlier, yeah, feel free to stop me. Okay. So yeah, then I'll go back to what I was referring. So maybe given I spoke, I'll not repeat the whole thing again. I'll try to speak faster. What I was saying is, given training data, preparing the data is important. I spoke about how Label Studio can help you annotate. So we take and label data, we use pre-trained model to predict, and then we correct it if required, and then we help it active learn, right? So this is a sample screenshot. Then I have set up Label Studio locally. I hope you were seeing the presentation. Are you able to see my command prompt browser. Can one of you confirm, please? I can't hear anybody in case if any of you are speaking. Am I audible in first place?
Yes, sir, you're audible.
Okay, is my screen visible?
Yes, sir, it's visible.
Command prompt, browser, all of it is visible, right? Okay,
Yes,
good.
sir.
Okay, yeah, sorry. Okay. So behind the scene, I have started Label Studio. This is the uh, window where I have started it. I run the command. I have done setups required to do that in interest of time. So you can download it. I am using Anaconda, which is a very popular tool for development. So I have taken Anaconda. I have created my own workspace called Label Studio, and then I have moved to the directory required, and then this is how I start Label Studio. Sorry, it just keeps logging. So Label Studio start, and then this is the project name I'm using. So here I'm using a BERT classification model. So if you remember the earlier session, BERT is one of very popular model. It's based on transformer architecture. So using BERT, you can do NER, classification, Q&A. In this case, I'm doing a classification task. Okay, so that's what I'm doing. So I've created a project. I have set up the project to do the required things. So in order to set the project for annotation, if you go to setup tool, based on the task you perform, right, you have to configure the labels. So labels are the ones that will tell you whether you are doing a classification or NER and stuff, right? So this is a configuration that I've changed. So I can choose one of these for, so let me explain what is the use case. So there are many financial statements, documents, income tax papers, all that, correct? So this model, when you upload a document, it will kind of understand the content of the document, and then it will predict whether it is IT returns or it is income tax or a federal income. Sorry, this is more for United States related documents. Uh, we kind of demoed it for one of the third party, so I'm just using that. So so based on what kind of document is, I will choose one of these, and then once I build a few examples or enough examples to train the model, I will click train, the model will get trained, and then it will help predict. So this is the initial configuration that I have done, so that in the UI I can see these options, because every problem is mostly unique, right? For example, if you were to do a sentiment analysis, for that classification, your labels will be positive, neutral, negative, right? So if you were to classify a document like this, it would be based on the types of document. So every problem might need its own label. So the first thing you may have to do is come and change the labels, set the required details so you can start labeling. So assuming you are setting this afresh, you do these configurations. Now you can import documents and start labeling, right? So before I label, like I said, always our intention is not to start from scratch, right? There are so many pre-trained models out there. So why should I start from scratch? So with that, what I have also done is I have taken a BERT model, fine-tuned classification model, and then I have also started it in another window. So if you look at this window, which is already running, you can see that. So again, it's Label Studio. I have tuned it or configured it for Label Studio. So you can see, you see Label Studio ML, which is ML backend. I'm starting the backend with a command start dot classifier ML backend. So what does backend mean is your label studio is your front end through which through UI you can annotate, review all that. And then once this is ready, you can click train button, which will trigger the training. The label studio UI that you see in the screen, right? This will communicate. If you see this model tab, this model tab is where I will have all my models listed. Usually this page takes little time. So when it loads, you will see a model, a box representing that model. You can see bird classifier, ML backend, what port it is running. So you can see it is running on 9090, which is it is connected through HTTP ports. So you can see it, this is running on 9090. The actual label studio is running on 8080 port numbers. You can see what is the model version and then whether it is connected to my label studio and model, whether they are connected or not. You can add more backends here. Yeah, I can add a NER model, question answering model, and so on. And then you can switch to what you want to get connected, and then you can click train, which will start the training process. Usually training takes little time, even though it is small data set. So um, I've just ran it once when we discuss that part. So this is how you kind of get the ML backend ready. So just to summarize so far, you set up Label Studio, you install it, then you go to setup, configure the labels required, and then you come to the model tab and then start the model backend and then connect it accordingly. So once this is connected, you are all set to start labeling. Okay. Given this is demo, I will maybe frequently check any questions so people don't get lost. Any questions so far? Okay, I'll take that as a no. So once the backend is connected and Label Studio is set up, you can start labeling. Okay, um, so in order to label, you can click import and then you can import a file. So I have already bunch of input files gathered in one location. I have more federal income tax documents and then financial statements. These contents, typically they would be documents, right? So we have used OCR and few techniques to convert them into this content. So that is what you see here. Now let's go to import and then import one of the document. So I can click drag and drop. Let's say I want to label the first one, let's say. So when I click open, it's going to immediately create a task. So why is it creating a task? If you think about it, we discussed that we need many input records for training a deep learning model. If you were to train lakhs of records, right, you need a team, right? If you need a team, then you need to have many login accounts, and each of them need to be assigned a task on what they have to annotate today, all that, right? So when a file is imported, be it an NLP document, text document, or image, or audio file, video file, whatever it is, it will create a task. And then you can go to explore tasks and then see list of tasks that's assigned to me, for example. So these are some of the tasks I have already completed. You can see the completed task I have is 5, and then pending total is displayed here. Okay, so you can view the task, the document, by clicking this eye icon. You can also see when it was completed, what content it has, all that. Okay, so this is the recent document that I uploaded, right? So I will click this to view. So you can see initially nothing is predicted. because it's a new document, we opened it, but after some time you can see this got automatically selected. I didn't do any magic or anything like that. Behind the scene, when this document was loaded, because we are doing active learning, the document, when the task was loaded, this content was sent to ML backend. And then ML backend predicted, ML backend predicted what is the document, what it is classified, and then it returned what is the expected result. So as you can see already, I have not done anything much. Um, I load a document. If it doesn't even understand what this is, it's not going to give me anything pre-selected. If the model has learned something based on my earlier annotations, it will do its best to predict what is right. If I think this is right, I can leave it as it is and please simply click submit. If I think this is incorrect, I can always change it and then I can save it accordingly. So no ML model is 100% accurate, right? So obviously there will be some error records. So the percentage is what will vary. So as you upload for,
Excuse me, sir.
yes, ma'am.
Sorry for the interruption again. So the screen is visible but couldn't able to read the text. So if it's possible, can you please try to change the layout? Most of the
Sure,
participants had posted in the chat box also. Couldn't able to read the.
sure. Okay, is this better? I think this content you don't have to worry much.
Okay, sir.
Because it's just document content and it may not make sense when you read it. I think the key takeaway is how is the document classified? What are the options you have? The options you
Okay,
see here
sir.
is based on the label configuration. And these are the options we configured, right, when we set up Logi Studio. So we kind of, it displays that. And another important thing to note is it automatically predicted and selected this. That is what is very important. I can choose to correct it or keep it as it is. And then if I click submit, this task will be marked as completed. Okay. So, so even these texts are not visible, is it? Maybe I'll make it a little bit larger. You can see all the tasks. It's simple UI. I think we can. I mean, you can spend some time. I think the key takeaway I want all of you to have is how model is able to enable you to annotate faster and build models faster. That is the key takeaway I want you to have. Okay, so if you go to tasks, you will see that the count is increased, completed, and this is also completed now. Okay, so like this, I can correct any incorrect predictions, and then I can acknowledge, okay, these predictions are correct. I will simply save it. By doing this repeatedly, I will have a good corpus to train my model. Once that is in place, all I have to do is go to this models tab, and then you have seen the training button earlier, right? Click the training button. It will take all the data that we have annotated so far. It will feed it to the model and then train. Usually, like I said earlier, training takes some time. There are many iterations that it runs. As you can see, when I clicked last time, it started and you see various iterations, how it's making progress, and finally it will complete the training. So once the training is complete, the latest model will also be available for you to further annotate or make prediction. Okay, so if I'll click the training button and then we can discuss few other things and we can come back and check. So important thing to check is whether this connected button is green, and whether the expected model is in place. If so, you click training. It will connect to the backend model server to running on this port, and then you can see the training is in progress, and then you can also see it will show starting the training process. Sorry, does anybody have any questions? I hear some background noise. Okay, so as you can see, it has started being boxed and various iterations. So pretty much this is what I want to cover part of annotation and active learning. The good part is Label Studio supports many formats, many like audio, video, and so many things. It's as you can see in this website, you can annotate images. Say if you are doing image segmentation is where you have to cover all pixels, right? See, this is audio file. You can annotate audio, which part of the audio means what. This is NER, and this is image. It supports various file formats. So going back to the slide, what we were discussing. So you can see part of training. Important thing to understand is how do you annotate. Definitely anybody, be it you are from industry, ensure anybody doing ML or this is not only deep learning, this can be used for machine learning projects as well, not the exact tool, but the concept. And ensure your team or anybody leverages active learning. It makes a huge difference. The human in loop is what I showed when I reviewed the model output. You can correct and then annotate it for further training. That kind of completes what I want to show in terms of annotation and review. Um, any questions before we move to NLP tasks based demo? Okay, I'll move on. Okay, so next thing I wanted to show to all of you is Hugging Face. If you remember in our previous session, we discussed how Hugging Face can make things very easier for you, right? So we spoke about what it can do, many tasks it supports, and stuff like that. We'll start with, I have a notebook running on Colab. Colab is a Google provided notebook environment where anybody, it's free of cost. They give you free GPU and also TPUs if you want to run very resource intensive stuff. Let me switch to that Colab screen for a minute. So the URL is collab.research.google.com. If you go to this website, it will prompt an option to load any examples or use anything recent. You can load notebooks from Drive or GitHub, or you can upload your own files from local. So what I'm going to do today is show this notebook to you. But before I do that, even without getting into a notebook, setting up the environment, and then trying to learn this, right? There is even much easier way. So let's start with the even much easier option, which is Hugging Face website itself. Your Hugging Face website, you are able to see my browser, I believe. Please, one of you stop me if you don't. So this Hugging Face website, like I said, it has so many good things. It has a repository of models. So if I open this in a new tab, you can see, remember each task that we spoke has a trained model associated with it, right? So you have various tags based on which you can search the model. For example, if you want to do a NER model, you can choose
Excuse me,
NER.
sir. Excuse me, sir.
Yes, ma'am.
Sir, your screen is visible, but the letters are too small. So we
Okay, ma'am.
cannot think of it.
I'm
Yeah.
increasing it. Is it
Yeah, the
better now?
font. Yeah, yeah. It's fine.
Okay,
Yes, sir.
okay.
Thank you, sir.
Oh, sorry. Don't
It's
wait.
true.
Let me. Sorry, one second. Sorry, there is some delay as well. Pardon me. Is this size okay? 150%?
Still little more, sir.
I'll make it 200 then. Okay.
Yeah, this is fine, sir.
Okay, fine. Okay, so if you come to this model repository page, there are tags in the model. You can go by what framework you want, what serving you want, what format. ONMX is a standard format for model training. Text classification, token classification is actually NER, and then you have translation, summarization. So let's do a token classification, which is NER. I'm selecting this. You can see the search results are filtered based on only NER related models. There are so many models you can see. You can keep scrolling. There will be hundreds and hundreds of them. Right? And many people, they build their own models and then fine tune it or just contribute here as well. So let's open one of the models here. Let me open this. I'm opening it in a new window. Size is good for people to see. So it gives you the model name and the different tags using what it is built, what is the model details, what task it is, all that. So let's come down. Okay, so you can simply type a statement here and then you click compute. It will kind of do token classification for you. Let me try it. Again, live demos are usually riskier. It may fail, and this is like third-party website. I'm keeping my fingers crossed. Hopefully, things go well. If not, at least you'll get the idea. Okay, so let's try. Okay, so the model is currently loading. It usually takes some time. Let's see what happens. While it loads, let's open a couple of other models. I think let me open this as well. When I open this, I have seen this earlier. It comes up with some example built. See, for example, my name is Clara and I live in Berkeley, California. Let's run this as well. Okay, because it's pre-built example, it didn't have to load the model. So you can see for this text, my name is Clara is recognized as a person. PER stands for person tag, and I live in Berkeley is detected as the location. California is also detected as location. Um, you guys can follow me, right? So far?
Yes, sir.
Okay, so it's still loading. Let's see. But I'm sure you got the idea. If I change this to, let's say, Daniel, and let's say I live in Chennai. Yeah. I don't know if it will do Tamil Nadu. Let's see. India is fine. So a compute again is going to mostly load. It may take some time, but if the model is trained on, I think Chennai, India is pretty popular, at least India. So I believe it should produce the output. Okay, the whole point of showing this is you don't have to necessarily know to code, set up an environment, and then understand all these. You can just go to this website, give your input, and then get you can get a feel of how this is working. Okay, I think they also have APIs. Sometimes they are not available, so I'm not sure APIs will work. I think we can. I think this is good for now. So this is an example of how NER task works. This is without much coding, all that. I want to show, so anybody curious to learn can go and check this out. Okay, so yeah, some issues with loading the model, but I think NER we saw some examples. So with that, let's move on. If you were to write the code, right, whatever examples you see here, if you have to just write this in a notebook, all you have to do is scroll down to that page. You can copy paste this in a notebook. If you have set up Python required libraries, all you have to do is copy paste this content, run it, and then you can change it to any content that you want. Okay, I'll talk about training briefly, but this is straightforward inferencing. Okay, um, again, like if you remember the machine learning flow, um, training is one part, then predicting is another part. So what we are now doing is directly predicting on a pre-trained model. Okay, so yeah, so this is NER with sample code, all that. I think, and there are documentation on how accurate this is, all that. As you can see, F1 score is 95, which is very, very good. I believe it is like, I think for NER, I'm not sure about the human performance. It should be mostly exceeding human performance accuracy. Okay, so let's try a few more examples. We can try question answer, and we can try classification. Let's do that. So let's you can switch to go here, text, select classification. We will remove token classification, and then you have this. Let's check this. Let's open up 2, 3 of them to see which one has pre-built examples. Okay, so this is I think we showed this in the PPT as well, but if you were to just compute this, you can see I like you, I love you is positive. It's 100% positive, 100% confident that it is a positive statement. Again, if I change this, it's going to load the model. It may succeed. Let's try. So let's just change it. I don't like you. Let me say it will try to load the model up. It loaded pretty fast. So you can see um, it's like 99.99 whatever percent. It's negative. Okay. Given this works and it's faster, let's try some more statements as well. Uh, okay, so I think I'm making very similar statements. Um, See, I didn't use any like or love or those words, but still it was able to figure out positive and negative all that. So this is a sentiment classification model. So it's giving you whether it is a positive or negative sentiment. Again, I think last session, I'm not sure if the person is there, but we spoke about hyperparameter tuning, right? So you can see they have listed down some of the hyperparameters. Generally, when we do iterative training, batch size is very important. So you have batch size, mass sequence length, number of epochs, standard thing, learning rate, very important. So these are some of the standard typical, most of these are applicable for many models. So that's classification. Let's check a couple of other examples. Anyway, it's pretty much, they are different models, but all these, I think you can see the labeling, what they've done is different, but label 0, it's not properly, somebody has hosted this, but this should be like positive and this should be labeled as negative. Instead, it's like label 0, label 1. But you can make out from the example. This is Roberta. So this one is Roberta. This is Distilbert. Like if you remember, last session we discussed the benefits of Distilbert. Distilbert, again, I mean, numbers as per what I could remember, it's 90% accurate, as good as bird, but it is 70% lighter. So it is only 30% of bird. So that is distal bird. Probably that's why it loaded fast. Let's try robota. Again, I didn't try some of these before the demo. I'm just going by what I see here. So let's say um, okay, as you can see the difference. Roboto model is pretty heavy, and if you remember the graph, just to give you some context, you can see make it full screen. So Bird has just 66 million parameters, whereas a robot is also not bad, but yeah, it's probably 6 times more, close to 6, 7 times, yeah, 6 times more robot. So probably that could be one of the reason it's taking time. Anyways, so I think you got a hang of it. Let's move on to one or two tasks and then we can run some more stuff. Any questions so far?
Sir, there are some questions.
Sure, let's take it.
So one person has asked, like, I want to try this sentence. I want to play cricket, but it's raining outside.
Sure, let's try it. Let's verify this works. It works. What's the statement again? I want to play cricket. Huh?
Yes, sir.
It's negative. Probably because I'm thinking the guy is not able to play it because for some reason, right? That could be the possibility. I want to play cricket, and let's say, I don't know, it may still may give negative. Let's say, instead of but, usually you may not say but if it is nice sunny, right? I want to play cricket, and it's nice weather. No, nice is positive. Anybody, you want to try something, do the same thing but make a positive statement. I want to play cricket. It's sunny outside. Let's see. If I say nice, it's going to make it positive. So just try. Yeah, it's sunny outside. So I think it's trying to understand because you're doing a bird. You wanted to do something. When you say bird, it kind of inferring maybe it's negative. Just guessing. Or many statements with rain outside could have been tagged negative because play and rain may not go well. I'm sure it would have learned from all those things. These models are trained on very, very large corpus. I think a complete Wikipedia, then I think millions of books or something. I forgot the exact number. Bird-based model itself. Robota is trained on top of it, but this is distal bird. So anyway, it has similar intelligence. Did that help, or anybody wants to try any statements? Let's. Anybody wants to try any statement? I like this actually. It's little go negative. Let's see. It's negative. Yeah. Yeah. Any other questions, ma'am? Sorry, let me switch to window. Next window. Maybe you can read it for me if you have it. And I don't know which window it is. Any other questions, ma'am?
Sir, one of the participants had posted in the chat box What about the data file safety? Is it safe to upload in Hugging Face? It's
See,
just
obviously,
purpose he is asking, right?
yeah, see, definitely you should not use it for, yeah, you should not use this for any confidential information. This could be logged, this could be for further learning and stuff. Obviously, anything sensitive you should avoid, and encouraging more from learning point of view. Anyway, like the notebook and stuff I said, you can do it on your local or your own cluster or VM. And the same code what I am showing, right? See, I'm starting off with a easy note. So anybody who doesn't know programming also can go and try these things. That is my intent. But anybody with programming capability should definitely go with my next demo. To answer your question short, yeah, don't go for it if data is sensitive.
Thank you, sir.
Any other questions? Okay, we'll move on then. So we tried NER classification. At Q&A, we will try one, and then we will move to notebook based in interest of time. I mean, we can see text generation. That's an interesting piece. I'll show that after question answer, and then we can move to the notebook. About again, loading might take time. Let's pick a Distilbert. Start with Distilbert. What's my name? So the context again, if you remember, question answer needs two inputs. You need to give the context and then ask a question. So here, my name is Clara. I live in Berkeley. What's my name? That's the question. So let's try this. Clara is the answer. Let's again. I don't know if it will take time to load. My name is Daniel. I live in Chennai. Let's try this. It's loading. Hopefully it loads. Otherwise, at least you have a feel of how it's going to work. Same. Squad data set we saw today morning on the benchmarking and stuff. There is no sample code on this page, but I think this also, if I click compute, it may run for long. This one I think will run quickly. If I change it, if I just change the name, it's related to it. Anyway, I have notebook demo, so don't worry. If it doesn't load and show, that's fine. Okay, so I think at least with the Clara example we saw, it's able to detect name. And these examples are trivial, but don't judge its capability just with this simple demo. It is really, really good. We have tried it in few projects. We scraped many contents from internet on for a biomedical project. The results were amazing. Even humans, we were not able to find certain things, but model was able to find so many details. We were supposed to find like 20 fields, some of them using NER, some of them using question answers, some of them using classification, and question answering results were very, very good for real world scenario. And for example, just for training purpose and other activities, we in fact even tried scraping some Cricinfo articles, and then we asked questions like which bowler took 10 wickets in a match and stuff. It was able to display the correct answer. It was that good. Okay, so with that, let's move on to notebook demo. The other thing, maybe today morning, I showed a nice visualization of co-reference, right? Maybe let's see that and then move on to this is text generation. We will look at it next. We will look at this first. You are able to see my co-reference visualization, right? Okay, so let's try that. What did we try last time? So in the PPT, I gave an example where let's try. My name is. there is no co-reference here. Maybe there is a reference I, yeah. So my end, I prefer to obviously name Daniel. So this is a simple co-reference. Um, let's try the PPT. I used an example where I lost. Is fine. Daniel lost. Right. Keys. So Daniel lost his and Daniel are reference, and then by keys and it is a reference. Okay, so then we can switch to text generation. This is a pre-built UI from Transformers team. Obviously, whatever I'm showing here, you can do it using APIs and SDK also. See here, you can see some conversation already loaded, where Tesseract plan. I think this is the Thor movie dialogues. So if you look at this, if I press tab, it will suggest auto-generated text. In fact, the text you see here itself is auto-generated to my knowledge. And then you can also use up and down arrow to select the selection. So all these are like AA based on training data. Okay. So if I pressed just tab now, let me increase the screen size. Sorry, I forgot. I hope this is visible. So when I click tab, what happened was I even got triggered, and then the API call was made to get possible predictions for the statement based on the statement made so far. So you're going to stop me, and then what will be the next possible statement? This is like statement prediction. So if I select this, then it will have it as a next dialog, or I can complete the statement by saying I'm just going back to Earth and so on. So I can just do this, and then I can press, if I say Steve, I'm not sure, press tab. So it gives me how I could start a statement, how, what, and so on. So, or you can just do a shuffle. It will completely start with a new example. So let's try our own. I hope this works. So say the statement the one of the participant gave. I want to play. If I say play and then press tab. So usually play could be followed with I want to play with me is ridiculous. Play on the right path. Play it. Play it could be on an instrument, right? So I want to play. It's based on what statements it has seen. It is trying to look for possible words that can follow the statement. In our case, let's complete the statement with cricket. I want to play cricket. I press tab. Now it has got the context, and statements will be based on cricket. Again, I don't know what this model is trained on. I want to play cricket. Uh, should I bowl, or let's see what happens. Play cricket if that is the case. Play cricket and it doesn't seem to predict well in this case, but I hope all of you are getting a hang of what this does. I think there are many. This is GPT-2, GPT-3s, and this is more distill GPT-2, so which is expected to be lightweight and perform not as great as GPT-2. But GPT-3, the model name highlighted here, it is 2, but 3 is very, very amazing. People are worked by what it can do. So this is a UI built, and then we are seeing this. You can do it in like a chatbot conversation. You can easily apply some of these things. Okay. Any questions so far? I think it's already 15 minutes. Any questions?
Participants, any questions from your side?
Sorry, I can't hear you clearly. Please come again.
Sir, I think no questions from the participants. You can
Okay.
continue with the session. Thank you, sir.
Yeah. Okay. So I hope it is of interest to you. I hope I'm adding uh, some sense here. Okay, so now let's come to the notebook part. Typically, programmers, ML engineers, and so on, they use notebooks to write stuff, right? So, what I've done is I've prepared some basic stuff where I am installing the required libraries, transformers, Spacey, Torch. Spacey is another NLP library, good one. So let's run one by one, and then so you have to press Shift Enter, or you can just click play. Click run anyways. This might take some time to download some of these things. Um, okay, I think most of this is already there. Then while this runs, let me explain the code. So I think in morning session PPT, I kind of explained this at very high level. Um, for you to do a NLP task, you define a pipeline. A pipeline involves multiple things. If you look at the documentation, right? So you can see you need a tokenizer, you need a model,
Excuse me, sir. So can you
cortex
please
space.
increase the
Sure,
font?
sure, sure. I'm sorry.
Thank you, sir. Thank you.
Okay. Maybe you guys are used to college students not getting what you say. So just pardon me in that sense.
It's okay, sir. Thank you.
Okay. Okay. So I hope this is visible.
Yes, sir.
Fine. So if you look at the documentation, you can see that a pipeline constitutes of many arguments. Many of these are assumed to be default. Based on the name you chose, it's going to decide the pipeline, right? So um, we spoke about embedding all those concepts very high level, right? So tokenizer is the one that will kind of enable you to tokenize the word based on a model and embedding you chose, and then prepare the text that you pass to the format that model can understand. So in this case, both are assumed to be the defaults. And then here you can see some examples where you can pass NER, you can pass question answering, you pass sentiment analysis, you can do mask filling. I remember the MLM task we discussed, masked language modeling. You can do summarization, text to text generation. There are so many things. Documentation is really good. If you read them, I'm showing it like just a mouse over, but you can go to that website, read documentation, and then comfortably do it. Okay, so I have defined a sentiment analysis pipeline here, uh, which will pull the required tokens, required models. By default, I believe it is Distilbert because Hugging Face promotes Distilbert very much for learning and development purpose. Then you get the NLP object as the outcome of this pipeline. And then as we did today morning, you pass the example, I hate you or love you. And then it returns the label with score. So let us try it. So I think this pip install is complete. Let us run this. It's taking more time than usual. Not sure. Let's see. Okay, that is good. So for the statement, I hate you, the label is negative with a score of 99.91. So as we spoke earlier, a score is usually the confidence level or the probability that the model thinks this is correct. So in this case, it's pretty high confidence. If you run the statement, I love you, it is pretty fast because the loading all that happened, it's pretty fast and it's even higher confidence. We can change, try playing this. I can make a copy of this. Let's change it here and run. So try what we tried in the UI. I want to play cricket practice site. So it's negative. Let's try this. I like phones. This also I think will be negative. If you want to try anything, let me know. Otherwise, we will move on. So that's on sentiment analysis. You can try this for any text classification as well. And then we have question answering task next. So you have pipeline defined as question answering, and then you define the context. Context is any paragraph of content. You can copy paste from anywhere. In this case, we have gone with whatever came with the example. And then once you initialize the context for the NLP object with the pipeline, what it returned, you can pass the question and then the context. This is pretty much what I showed in the BPT today morning. So this will return the results which you can print here. So let's run this, and then this, and then this. Okay. Okay, so if you read this passage, extractive question answering is the task of extracting the answer from the text given in a question. So that is the statement, and there are example of a question answering data set, square data set, and so on, right? So what's the question here? What is extractive question answering? And if you read the answer returned, the task of extracting an answer from the text given a question, that is the answer for this question. Okay, so going forward, if you are tired of preparing question and answer both, I think see, the thing is, it will give you part of the statement or very rarely full statement. It will never give you like 2-3 lines. That's how it is designed. So if you are expecting a paragraph or something, you have to post process the start and end location, and then you have to produce a little larger output. So the in question answering or summarization, there are two things: extractive and abstractive. So what we are doing here is extractive question answering. Then for the other question of what is a good example, it has written the perfect answer of square data set. See, there the sentence is larger, bigger, because only if it gives you all these words, it will answer that question. But whereas for a question like this, it is smart enough to just give you this. Again, for you to build something like this, right? If you think about your labeling, annotation, all that, you will ask this question, you will annotate saying for this question, this is the answer. And based on how you label the data, the model will gradually understand it. I'll take a pass. Any questions?
Sir, one of the participants, Mr. Pavan, has asked one question. Will companies use these Hugging Face models for solving real-world business problems?
Absolutely. I am my team. We are a big fan of Hugging Face. We use Hugging Face for almost all our projects. We these days that's our number one choice. Yeah. And you can see how easy it is. Otherwise, you would write large lines of code, which is tedious, and Hugging Face is pretty good. Did that answer your question? Any further questions on that?
No, sir. Thank you.
Okay. Yeah. So next thing is NER, named entity recognition, where this is uh, we have seen already named entity recognition, what it is. This text here talks about how to label it. So if you remember, for certain NERs, there were 2 words or 3 words, right? So the first word should be marked as beginning word. The any words in the middle will be marked as intermediate, I. So if you have just one answer, one word for to recognize an entity, you simply tag it with B hyphen whatever. So what you see here is abbreviated form of the entity name. So org stands for organization, PER stands for person, MIS miscellaneous, LOC location. So you can come up with your own tags. If I want to build a model to recognize different fruits, I might say B hyphen APP for apple, ORG for orange, maybe strawberry, I can do STR, whatever, right? So if in case a fruit is 2 words, then I have to name the first word as B and the second word as I. I'm just trying to recollect on the fly whether there are 2 words fruits. I can't recollect now, but that's fine. Okay. So I think even words like gala apple, for example, here gala is variety of the apple, but you want to highlight both gala apple, Fuji apple, or I think Washington apple, whatever, right? So in this case, your gala would be B and apple would be I, because you want to highlight both as a one single entity, right? So this is how behind the scene things should be tagged, and then it should be fed to the model. This is called IOB tagging. O stands for outside, I for intermediate, and B for beginning. So this is when you train the model. So I just wanted to convey it so you get an idea of how training data for NER is prepared. So here we are initializing a pipeline with NER, and then once the object is returned, we are creating a sentence. Again, this is Hugging Face example. Let's run this, and then you kind of print the okay. So if you print it, what I have done is just to make it visually appealing. Hugging Face doesn't have a library to color code the NEAs identified like this. You see the cyan color, yellow or amber color, the gray color. This doesn't come with Hugging Face. So sometime in projects also we do this, where certain things are good in certain libraries. SpaCy has a good, this is called DisplayC. You can see I have created here. So I am using DisplayC, and yeah, in fact this whole example is spaCy. But what sometimes we do is we take the output of Hugging Face, and then we simply use DisplayC alone for us to display it like this. Because when you review large content, right, it is easy for you to highlight things like this. So it is easier for you to review. So we do it for that purpose. So in this case, we have loaded a spaCy library, which is just a web. SM stands for small. It's a small web library, English. We load it, and then we pass the string. In this case, we're using the same string. And then DisplayC has different renderings options. So we are displaying using Jupyter True, and then we are setting the style to entity. There are different styles. In this case, it's entity. So once I do that, you can see Hugging Face is recognized as, or New York as GP. GP stands for, I think, global geographic position entity or something, but GP is kind of location. it's headquartered in whatever location, and then FEC, I'm not sure what FEC is. So it is recognizing these entities. Okay. So then let's move on to summarization. It's again, it's an entity that the model is trained on. So I think it's kind of uh, maybe an important location or something. Okay. Then any questions so far before we try summarization and translation?
No questions, sir.
Okay, fine. I think as we do this, it might become more monotonous because we take a task, fill it, and run it. So here, pipeline and summarization, the article, we have a larger article. So let's run this, and then we will call print summarize. So it's going to summarize the article. I think it's set to run, so maybe, okay. I think this has some problem. Let's check. We'll quickly check, if not, we'll move. Pipeline is not defined. 1 second. Sorry, I remember running this, maybe I made some last minute changes. From the documentation, we have to see what's the right text used here. Let's move on to the next example. Okay. Then translation. Let's try our luck here. Same thing. Write out. Let's rerun this whole thing. Write out something. Let me see if I have earlier ran outputs in there. See, even the older ones are not running. 1 second. Let's wait for this pip install and try one example we ran earlier. Okay, I think anyway we are almost. I was planning to show summarization in generation. Given I have shown generation through that Word document, pretty much I think that is all I want to show for the demo. I think since we didn't run those two examples, uh, I'm almost done with what I want to show. I can take questions, and if you want to discuss any specific details, we can discuss. And any questions?
Participants, any question from your side? Sir, again, Pawan has asked one more question here, Mr. Pawan. NLP
Yeah.
versus computer vision, which has more scope? NLP versus computer vision.
I think both has a lot of scope. I think it's difficult to say one versus the other. I think I would say both has great scope. I think it's more of a preference. If you personally ask me, I like more vision, maybe because of the, I mean, it's visual images are more appealing than text, right? So I like when I do any vision related output that excites me more than NLP. But some of my team members are diehard fans of NLP tasks. So it's more of a personal preference, but scope wise, both have great scope. There is nothing like one is not so great versus the other. because the use cases are so vast. They can be used so many places. You cannot understate one versus the other. Both are both have great scope.
Thank you, sir.
Welcome. Anything else? Sorry, I think we have 20 minutes left, but probably I went fast or I kind of completed it early. Um, yeah, maybe I'll share my details in the chat window if any of you want to reach out to me post this session. Please feel free to do that. Okay.
Sure, sir, sure.
So yeah, my email I should have added it to the deck. So, at 90.com. That's my email. And yeah, I think email is all good. I think if you want to reach out to me on LinkedIn, I think I'll just be my LinkedIn profile if you want to connect. But yeah, pretty much that's it from my side.
Sir,
Yes.
I have a question.
Yes, please.
So we have the audio recognition tool, that is Alexa. Uh,
Yes.
does it work on this sentiment analysis or question and answering?
It's more intent driven. So what happens is, in fact, we have developed few Alexa apps as well. If you go and look at the Alexa UI and how you need to train, right? Alexa waits for specific trigger words. When you, for example, when you want to say, "Hey Alexa, good morning," it understands a good morning as a greeting intent. Or if you ask, if you want to trigger an app, you specify the keywords, the trigger words. That's called tokens, right? Token classification, like in here. So those trigger words will trigger an intent, and that intent will route the queries to the particular app. And if you look at how apps are designed, again, it's all you have a predefined way of asking questions. So you kind of goes through that flow, and then based on what is your intent in the conversation, it's more of a conversational bot, and then it will kind of respond to your question. But even though I say it is primarily intent driven, I'm more referring to the way how skills are developed in Alexa. Each app is called Alexa skills, right? But you can also ask Alexa generic questions, or even Google, let's say. But those questions are pre-searched, indexed, and they are pre-computed. So when you ask a question, those questions pretty much go to an indexed search, and then it returns you a result. But to keep my answer short, it is primarily, I would say, intent driven, which is NER in first place. Okay, did that answer your question?
Yes, sir. But suppose we give some negative comments like Alexa, you're bad. So, but it doesn't respond.
Oh, is it? I think it's more to do. See, like I said, it's a conversational bot. Um, I don't know if you tried recent times. If you appreciate it, it would say so nice. I wish
Yes.
you have tried. I have Alexa at home, so if I scold it, it would say sorry to hear that. Maybe it is to do with the specific words it was trained on or conversationally designed. But yeah, they're definitely improving. Um, but yeah, I'm sure at least when I my kids at least just like that they used to scold it or appreciate
Yeah,
it.
yeah. Yes,
They
sir.
used to say so nice of you all that. But yeah, these are good use cases of NLP conversations. In fact, they are working on a research where they want to build Alexa or any kind of these like Google Mini, all that Nest, to converse with human for 15-20 minutes, like a friend or like a real person. The market for that is so huge, given the world we live. Um, And that to the situation, COVID situation, we are unable to go out. Maybe people at home are too busy sometimes. So if kids or parents, they want to converse with somebody, they want to make it so realistic. So they are making some design changes and they are working on it. I think there are some design challenges as well, making it more contextual related to the conversation. But that's in progress. I'm sure if not in 1 or 2 years, few years, we will definitely have that rolled out where you will see Alexa or Google Nest conversing to you like your friend or a mentor for 15-20 minutes. That would be amazing. And this will be expanded to domains like customer care call or where you have a query. It can convert. Already some usage are in these conversational spaces, but I think it will we will get there soon. That's why I see it. And I remember, I mean, I like personally, I like Alexa very much. I traveled to US that time, and it was launched for the first time. I remember I was so excited with their ad at that time, and we still we are amazed by how it works. It's really nice technology. Yeah, sorry, I think I gave a can, but I hope I answered your question.
Yeah, thank you, sir. Sir, participants are asking for your to share your PPT, sir. Will it be possible for you to share the
Sure,
PPT?
sure. Yeah, I can share the PPTs and demo notebook also I can share. Yeah. Demo notebook,
Okay.
I think you can find it in Hugging Face itself as well. I mean, it's broken down in different places, but I can share both. Yeah.
Okay, sir.
Anything else? Anybody?
Any more questions from participants? Thank you very much, sir.
Yeah, thank you. I'll close off with one note just before we close. AI is very amazing. See, I started off with like a Java person, then I moved to big data, cloud. Then I have been working in AI for a few years now. The I think the pure curiosity of how these things work drew me to AI. I strongly encourage all of you to understand this AI, be inspired by what it is doing. As you can see, it has the power to change the way we live. You can already see driverless cars and so many real world things happening. Already in US, there are many companies using driverless cars. I'm sure Indian road driving is different problem altogether, but it has already changed our life so much, and I strongly suggest all of you, recommend all of you to understand AI, be inspired. Once you have the interest, I'm sure everybody will start learning. So be inspired by some of these Alexa and other products you see out there, and the future is very bright for AI people. There are so many job openings. It is very interesting. Every project we take is very interesting from problem solving point of view. And from, I'm sure you will have more variety of AI courses gradually. More specialized AI courses within AI itself. I see that happen in few years or some years. So watch this space, learn with more interest, and reach out to us. You can reach out to me anytime. I'll do my best to help all of you, and also share your feedback, and that will help me improve my future sessions as well. Thank you for the opportunity. Thank you so much. Over to you.
Sir, there is one question from participant. Uh,
Yes, ma'am.
what what do you suggest to fresh engineers to go about with AI? How do they start learning, and can you suggest some learning platform for them?
Okay, so there are so many free materials out there. I suggest don't even pay a penny for learning this. There are Coursera, Udacity, EDX, and so many YouTube channels. People out of their interest and other things, there are good contents out there. So There are very less expensive Udemy paid courses as well, like 500 rupees, sometime in offer you get. You can take those courses, learn those courses first, and I showed Google Colab, right? So Google Colab is free. You don't need to set up anything. It's all virtual. You get free compute, TPU. There are so many open data sets out there. There are so many contests through which you can learn. So once you get into a forum, start understanding all this, I think you can easily learn from some of these contents. Pick your area. There are too many things. I decided to focus on deep learning. I consciously chose not to focus on traditional machine learning. So I focus on, at this point, NLP and vision primarily, because there are so many things to solve within NLP and vision. But I'm planning to focus on, there is something called GAN, generative artificial neural networks, which can generate content. It can draw creative paintings. It can it can write amazing stories. I'm planning to focus on that. And there is next reinforcement learning. The driverless cars and other real world things, robotic appliances you see, use more reinforcement learning. Reinforcement learning at high level is the model gets a positive or negative feedback for every action it does, and then it will correct itself. Like the cricket example I spoke, or tennis. When you play a shot, you will realize the ball is not to where you want it to be. So you will correct it. The result from the shot is your feedback, right? It is similar to that. So, and there is great future for reinforcement learning. But I think NLP or vision will be a good start. And there are plenty of courses out there. You can explore them. If you need any help, reach out. I can share the materials I am aware of. But did that answer your question?
Yes, sir.
Okay.
Yeah. So today, Mr. Sylvester Daniel discussed the concept of active learning using annotation, fine-tuning, masked language modeling, next sentence prediction, and named entity recognition. Sir also discussed some of the models used for text classification, translation, text summarization, and question and answering. He briefed about co-reference resolution and model development data cycle for AI and ML. And in the afternoon session, Sir has demonstrated the sentiment analysis, question analysis, text summarizations in Hugging Phase 2. So it was really a very enlightening session, Sir. So thank you very much for accepting our invitation as a resource person.
Thank you, ma'am. Thanks for giving me the opportunity.
Thank you, sir.
Thank you, sir. We look forward for the more association with you, sir. Once again, thank you.
Sure, ma'am. Thank you very much. Wish you a happy new year. I should have told it in the beginning. Have a great year and wish you all.
Thank you, sir.
Thank you, sir. Wish you the same, sir.
Thank you. Bye. Should I log off? Sorry.
Sir, if you could join for the valedictory, which will start after 15 minutes, sir, it will be fine.
So what time, ma'am?
After 15 minutes, around 3:45, at the same link, sir.
Okay, yeah, I'll join at 3:45.
Okay, sir. Thank you, sir.
Thank you.
I request all the participants to join the valedictory at 3:45 using the same Google link. Thank you all.